worked. So should go smooth, which, okay, I just jinxed it. So we'll see how that goes. So Barb, you want to come up and do your standard introduction? One thing I'll mention to folks in the hall, we have some windows open because there's no air conditioning here to try to get a little cross breeze and let things cool down. Probably sometime during the course of the evening, I'll go running around closing up some of the windows when things get cool. Meanwhile, Mark is taking off his jacket because it's warm enough. Okay, Barb, you're up.
Okay, there you go. So we pass out some sky calendars for July. I don't have August yet. I know you like, right? We still haven't happened though. And our next meeting will be on August 15th. We're not sure of the speaker yet, but we'll let you know. If you're not on our email list, be sure you make sure you put your email on the sign-up list over there. And we're just so glad to have you all here. And Leonard's going to introduce Shawn, and Shawn will give his talk, and then Leonard will give a little update, as he usually does, about the international space programs. And there's been a lot going on, right?
Too much.
Yeah. Okay.
I'm tired.
So you can,
Man, okay.
Watch your step there, Leonard.
Yeah,
Yeah.
I'll be able to.
chords.
Okay, what we're doing here,
Yeah. You're introducing Shawn.
of all the things in my life, I'm a reporter for Space.com and Space News and some other people. You know, when you think about space environment, it's almost an oxymoron in a weird way. You think space, you think environment. But when you put the two together, that's odd. And people love it because you see aurora, you see all these things flying by. And what I found out by going down to the prediction center in NOAA was I think we're learning as we fly. It's a great concept, and Shawn Dahl works there, and he was, you know, he's one of the best that I've run into for communicating to pesky media people like me. And he's been really forthright about all the things they know, what they don't know. And I think that's what's exciting. And I think the space environment, we're learning a lot of new things as more spacecraft go up. And you know, how we are going to deal with this when we send humans out to the moon and beyond, how the space environment is going to affect that. And so I guess my role here is Shawn has been an active duty in 2007, held several meteorological forecasting positions with the U.S. Air Force and the National Weather Service. So he was selected as our first service coordinator. Is that right?
Yep.
In 2023. And I think, you know, one of the strengths of this group has been him, from a journalistic standpoint, of having somebody that is willing to communicate both what they're learning, what they don't know, what they do know, and where are they going, because they're in the midst of a major number of initiatives that are going to make a big difference in our space weather forecasting activities. So Shawn, thank you for coming. I'm sorry I badgered you to come. But you were just so good for me, and I thought, got to communicate this to the general public, and that's his role. So thank you. Shawn.
Okay.
okay on that?
Yep. Look at this, John. I remembered to share screen.
There we go.
You're awesome. Thank you.
All right.
All right, take it away, Shawn.
Okay. Hello, everyone. Welcome. Thanks for that, Leonard. Such kind words. Thanks, Barb, Dewey, for bringing me up here. And before I get going, I first wanted to ask, who's that lovely lady in the back corner? Are you available? That's my wife, Cindy, back there. She's kind enough to join me tonight. So, yes, service coordinator. What does that mean? Well, I'm also a senior space weather forecaster. But we at the Space Weather Prediction Center, and by the way, I'm not going to call it Space Weather Prediction Center anymore because it's too long, so I'm going to say SWPC. SWPC for short, SWPC. So, SWPC has gotten a lot of attention as of late. Why? Because not only has the sun picked up in activity as it usually does in what we call the solar cycle, but there's been a lot of pretty extraordinary events that people have seen that have started to look them up. So the press and the media, as Leonard talked about, have come to us quite a bit more, so we needed to have somebody who could communicate not only with our core partners that we deal with directly, that you're going to learn so much about tonight. You're going to hear things that you never knew because you don't know that they're going on. But they're important to know that they're going on because then you understand why, as taxpayers, we're paying for an organization like SWPC. All right, I might need to, you said I have to do like a forward on here maybe?
The step forward one. Let me check real quick. There's always the odd chance I turn the power off.
Blame it on solar wind.
Yeah. Yeah. Is it working?
It wasn't, but I didn't try it again.
Okay. Blink. When in doubt, click the mouse. Okay.
Does the mouse need to be on this screen maybe? Oh, there we go. Now we're moving. I don't know what you just did, but. All right. All right, perfect.
There you go. You want that
Kick
slide?
in the pants.
All
Got it.
right.
So I was also asked because I enjoy astronomy, backyard astronomy, like many of you do as well, photography, to show a couple of things and try to relate it. Well, comets are not what we forecast at the Space Weather Prediction Center. That is not our role. That's more NASA and the colleges, universities and such. But I do love it. So back in October of 2024, you may remember that magnificent comet that was hanging out over the western horizon in the evening sky. So my wife and I drove up to Wyoming and took the beautiful comet pictures you see here over the windmill light landscape of Wyoming. Managed to get some great pictures up there. And then, of course, from our home in Berthoud, out over Longs Peak and Meeker Peak there. Total solar eclipses. So I guess my point was in 2024 there was a lot going on. People were seeing the northern lights, comets, total solar eclipses. This one is not from 2024. This one was 2017 when we drove up to Torrington, Wyoming, and that was a path of totality. So I was able to get some great eclipse pictures up there in Wyoming. But we don't forecast total solar eclipses either. But we do forecast what's behind the moon here, and that's what's going on the sun. One cool thing is oftentimes I work with folks at NASA for education outreach ideas. And one of the things I got asked to provide as the total solar eclipse was coming up 2 years ago was, hey, give us some stuff to talk about, because our NOAA administrator was going to be talking to folks in Dallas, Texas. And so one of the things I gave him was my astronomy picture, and then also a picture from what we call a coronagraph in space, looking at the outermost layers of the corona. So look what here. Here's these things called helmet streamers, coronal streamers coming out from the sun. So I thought, let me take my backyard picture at the same time a coronagraph picture was taken, turn it, and you can see the coronal streamers actually going out. I thought that was really cool. I passed that on to show all the mass crowds at Dallas Cowboys Stadium here in Texas. All right, so let's get into it. Why do we care about space weather? Well, we didn't in the past, but we sure do today, and we have to care about it today, as you're going to find out. So let's just look at the 20th century here. Some big storms. 1921, what's called the New York Railroad Storm. Why is it called that? Because railroads started having problems. Telegraph operators, telegraph systems were still in existence, started having problems. They couldn't communicate. Sparks were flying out of batteries. There was a fire at one of the stations, but also electric power was starting to come across areas of the United States. And up in Minnesota, in the little town of New Ulm, they had a massive transformer failure up there. all due to space weather. And I'll get into why that happens and why we care so badly today about what space weather could do for us. 1967, something that Dewey was telling me about. We had a little bit of a relationship here. His dad actually dealt with this particular storm in a capacity. I just tell about it now. I was only 2 years old in 1967, so I had no idea this was going on, but we almost had World War III. That is no stretch. What had happened was a massive event happened on the sun, unpredictable, this particular event, but other aspects of it were. And what happened is the sun became a giant jammer. And that giant jammer affected over the horizon radars all the way from southern part of the U.S. up into Alaska. So what do we think during the height of the Cold War in the late 1960s? We think that we're being jammed and we're going to about have them suffer a missile attack. So if it wasn't for folks like Dewey's dad and other Air Force weather officers, in which I've got a 22-year proud Air Force background, realized it was a space weather event, a solar storm that was going on, and they got the word out, and World War III never happened. Would it have happened? I don't know. And here's the interesting thing about space weather. We want our adversaries to know what's going on. Why, might you ask? Because they could have the same problem. Their radars might look like they're being jammed, and they think they're under attack from us. We don't want that to happen. So all of our information is about as public as we can possibly make it. 1972, storms that space weather induced storm started blowing up mines near Vietnam. We had the Vietnam War wrapping up at that point. They actually blew up mines because of a geomagnetic storm, a magnetic disturbance resulting from activity from the sun that arrived here at Earth. Dr. Dolores Gannett, who is also the one who's researching the 1967 storm, is also starting to find out that this storm was probably even stronger than we thought at the time. But there was also a massive solar radiation storm. So I want you to think about this. If you were on your favorite TV weather broadcaster, I don't know who that is amongst you, but they came on and they're talking their normal forecast and they said, oh, hang on. Oh, I've just been alerted. The National Weather Service has issued a solar radiation storm for the entire planet. Ah, might that freak you out a little bit? Radiation, we all think that's bad stuff, right? And it is. It's bad for astronauts, not so bad for us, because we're totally safe from our atmosphere and our magnetic shield that protects us. But if you're an astronaut in space, or a satellite in space, or operating in certain areas of the world, this could be a problem for the technology and for your human health as an astronaut, or even an aviator flying at high altitudes. And I'll talk about why all that is as we go. Finally, one of the more recent ones was the 1989. This is what made space weather become even more important when it comes to our national resilience of what we rely on, which is electricity, right? We like to turn the light switch on and the lights come on. They don't come on, that's bad. 1989 in March, freezing cold temperatures in Quebec, Canada. 90 seconds after a storm arrived from the sun, 2/3 of the province of Quebec lost power. Boom, gone. The northeastern part of our country almost collapsed, almost had a massive power failure that if that had happened, it would have looked something like this. Imagine all of New York up through Maine and the upper Midwest, just power gone. People would freak out, right? They wouldn't know what's going on. A major transformer at a nuclear power plant burned up because of this particular storm. So we don't want to see that happen today. So we're taking a lot of steps at SWPC to help make that thing stop. Make sure that the lights stay on, among other technologies that we rely upon. Now I'm going to go further back because you all need to know this word, Carrington event. That is kind of the benchmark storm that our government is planning for to be space weather ready. Why the Carrington event from all the way back in 1859? Because we know today that if that level of activity of a storm happened here at Earth, there's a pretty good chance we could have a major collapse in our electric power grid. Satellites could begin to deorbit and burn up in the atmosphere. They could collide in space, spreading a massive debris field across the low Earth orbiting levels where thousands and thousands and thousands of satellites continue to go up. Starlink, think of that as one small example. So much stuff is up there now. This would just be a massively catastrophic event in the world, for the world, let alone the United States of America. So what happened? Well, on September 1st or so, Richard Carrington, an astronomer in England, was observing the sun. He drew a massive sunspot group. He even put latitude and longitude coordinates on it, noted the date and time. And these two little white lights showed up around this massive sunspot group that he drew. He did not know it at the time, but what he was visually seeing, what's called a white light flare, a very rare event. Flares are usually measured in X-rays, but sometimes they can cross the spectrum and they can show up in the white light. So imagine the surface of the sun, a flare erupting that exceeded the surface brightness of the sun. That's what he witnessed. 18 hours later, the sky lit up around the world. People were experiencing the aurora globally almost all the way down to the equator. Islands, indigenous people that never seen it in their known life or ancestors' life thought the sky was on fire. Miners here in Colorado were waking up in the middle of the night thinking that the sun was rising, but it was like 1 in the morning. It was a massive auroral storm. The technology of the time was the telegraph system. That was the newest technology. So you had these telegraph operators slapping metal plates together, sending a signal across strings of copper lines going from states to territories across the United States, and they were operating on batteries because we didn't have alternating current yet. Well, the telegraph operators started realizing they were having problems, not only with communication, but sparks were starting, just like the 1921 railroad storm. Batteries started on fire, stations started on fire. There is a documented conversation between two telegraph operators discussing their problems. Even though this is Morse code, this is taking a little while, they're discussing their problems. And they finally said, let's just disconnect our equipment. Basically turn it off. They disconnected the batteries. They still had a signal. They could still carry on a conversation, and they did. They carried on a conversation with no power hooked up to the system. That scares us today. That's why the government cares about space weather so badly, is especially of the effect this could have on our electric power grid, what we refer to as the bulk electric system across North America. National resilience, grid resilience is a big deal. And if a storm like this happened today and we weren't ready, space weather ready, if you will, for something like this could be extremely catastrophic. Other storms. I got storms, litanies of them I could tell you about. Well, here's some more of them as we go into the 2000s, the Halloween storms, the near-miss event, the Bastille Day storm. You ever notice how space weather storms, if you read about them, they tend to have like holiday names? Isn't that weird? I don't know what it is, but they just seem to happen around known holidays. Maybe it's because there's so many of them today, there's always something to fall on. But either way, even look at this one. This one's very interesting, and this tells you another thing that we now care about, which is collision avoidance in space with satellites, because it's becoming overpopulated with satellites. SpaceX launched 49 of their satellites up, 38 of them burned up in the atmosphere within a few days. And there wasn't even a major space weather storm going on. It was a minor level event. Why? Because the atmosphere changed just enough. SpaceX didn't care about space weather up until that storm. Guess what? They care about space weather now, and they talk to us frequently about it. So yes, many different things. The near miss, we think that was a Carrington event that could have hit Earth in 2012, but it was 90 degrees ahead of Earth. How do we know that that could have been a Carrington level event? Because there happened to be a research satellite sitting there 90 degrees ahead of Earth's orbit, and it measured its strength, and it was kind of frightening. Not only its speed, but its magnetic intensity. Soldiers died. Our colleagues in the Air Force, Space Force, my professional career for so long, died because of a communication problem due to space weather activity. They didn't get the word, they went to go land, soldiers on a hill. They realized too late the hill was occupied by the enemy. They weren't able to turn them around because they couldn't communicate. They all died. They all got shot. So what exactly is space weather? Well, most simply put, it's what's taking place on the sun 93 million miles away in that huge vacuum of space between the sun and Earth, and ultimately at, here, and around our planet. Now, when I talk to FEMA, I talk to government agencies and work with them on exercises and planning, and I talk to emergency managers from city, county, state, and those national levels, we always consider space weather as a low risk. Low risk isn't the right word, but more of a low probability hazard, but when it does happen, it's going to be massively impactful if you get to that level of activity. So emergency management is starting to consider space weather and put it in their hazard risk assessment plans. And if they weren't, they're going to start doing it because the government is making that a known point of emphasis in today's administration. And why are they doing that? If we're ever going to have a $1 trillion weather disaster, it's probably going to be space weather that causes that. Because you can think of the massive number of satellites that could be deorbiting or colliding, powers dropping out, affecting billions and billions of dollars of commerce, GPS systems not working, causing delays in aviation and precision agricultural and drilling and fracking and all of these things that rely and can be infected by space weather. So clearly our government has an interest because we all rely on these things whether we understand or realize it or not. Drones. Drones are all over the place today. Can they be impacted by space weather? Yes, they can. Communications, line of sight systems can be impacted, or if they're plugged in by GPS, they most certainly can be impacted. So as I mentioned, our government cares. The current administration is no exception. One of the first executive orders released in March after President Trump came into office was achieving efficiency through state and local preparedness. That's a good executive order because that's getting into having states and local communities, emergency management planners, think about space weather. It's actually mentioned in the executive order. That's step number one. Step number two that they're doing is they're putting a national risk register together, and in the natural hazard section, they're adding space weather. That's not been on there before. What does that do? That brings more attention and highlight and the importance about space weather and what it can do to the technologies that we rely upon so much today. So that's really good. That's really good for SWPC because we know that they care about space weather. It allows us to continue to do our function and get new platforms into space that will help us do a better job of forecasting and understanding the sun. What do we do? Okay, so there might be a misconception that at SWPC, you know, before you came here tonight, that we're like doing aurora forecasts or something. No, we do not forecast the aurora. We do provide information because we know there's a huge interest in the aurora, and the aurora itself can actually affect some of the technologies that we rely upon, so we don't ignore it. But here's what we're doing. In addition to the normal forecasts and products and things that we're putting out routinely at scheduled times, when certain events happen, we pick up the phone and we're making phone calls. We're providing briefings. Look how this goes. We talk to the U.S. Air Force every day because our colleagues at Offutt Air Force Base in Nebraska near Omaha, they do the same thing we do, but they do for the Department of War concerns. So they're on the secret squirrel classified side. We're on the commerce, you know, general public side in businesses. Space launch. We call space launches entities if they've called us that they've got a launch coming. As a matter of fact, who's heard of the Roman Space Telescope? Mm-hmm. We're going to be providing direct decision support to that spacecraft. Why? Because believe it or not, that telescope, as it goes up in the atmosphere, there's a real concern about electrons. Electrons could hurt the instrument. So we're going to be providing some electron forecast support just because
Sorry, that was me.
Okay, because of the vulnerability of that platform. And of course, we've done it for many other launches that have gone up. You're going to hear about one that got postponed back in November by 24 hours due to a space weather storm. Transmission operation centers, power grid. We're already making phone calls at lower levels of important activity. When we get to a middle level of activity, what we call strong, and you'll learn about the NOAA space weather scales if you don't already here shortly, we're picking up the phone and we're making a hotline call to the entire power grid of most of North America. All the southern Canadian provinces, all the main 48 lower United States, the reliability coordinators, there are almost 20 of them that service that whole area, get on that phone call, we tell them what's going on, how long it's going to last, and what this might mean for them. Why? Because they need to know, because they're going to see things on their systems like those telegraph operators experienced in 1859 that's going to hurt their systems. And I'll get into the details on that later. All the way up to FEMA. We've talked to the National Security Council and the White House Situation Room about space weather storms. When we get up to the 4 out of 5 on our scale, they start wanting to know what's going on and what's happening. All the way to the public and the press and the media. So what is it? Why are we hearing more about space weather over the last several years? Well, that's because the sun, interestingly enough, is kind of a variable star. It's variable magnetically. So its magnetic field shifts roughly every 11 years. And as part of that natural process, there creates a lot of transition time where the sun can become very magnetically complex. Just imagine all the complexities going into that changing of the polarities on the sun. And that results in activity increasing, so the sun becomes much more prolific and active. You'll start to see it get littered with sunspot groups. Some of these are large enough that you can see with your eclipse glasses or your special filtered telescopes and get pictures just like this from space from your own backyard. And we got a ways to go. Solar max, the peak of solar cycle 25, which we're currently in. So we'll go from a minimum of activity, that's where the solar cycle starts, to a maximum of activity, and then back down to a minimum of activity. So the peak is going to be probably somewhere around 2024, 2025, but the experts will claim when that is. So we're starting to come down. But here's the really interesting thing about space weather and the sun. The sunspot groups migrate. So when they first start to show up in a new solar cycle, they develop at the higher latitudes of the sun. And then as the cycle continues, they tend to migrate and show up closer to the equator over time. So when you get to the peak and start to come down from the peak, a lot of the larger sunspot groups will be clustered around the equator. Why is that important? Well, if they're down here on a brown ball, activity might go down like this and away from Earth. But if they're at the equator, they could head directly towards Earth. So we've actually had some of the largest solar storms we've had have been 2 to 4 years after the peak. So guess what? Even though we're going to see less of these events, some of the most severe ones could still yet to materialize this year or next year. So we're definitely not out of the woods yet. So NOAA Space Weather Scale. Who knows the NOAA Space Weather Scale? Mark does. Lawrence, a few others, Leonard. So we've got a 1 through 5 scale. So you've all heard of the hurricane scale, right? Okay, you can have winds that are below hurricane strength, like tropical storm force winds. So if anybody's been from Florida or those coastal areas, you may be very familiar with tropical storm warnings. They can be deadly. They can be very catastrophic in what they cause damage to, right? But they don't warrant hurricane status, so they don't get that hurricane scale attribution. Same with space weather. We can have activity that's below these ones on the scale that we're warning about, and we do. But now you get to a certain level, okay, it warrants NOAA Space Weather Scale attribution. So even though we call an S1 through G1 storm minor, it's still pretty significant. All the way up to moderate to strong, this is where we're calling the entire electric power grid of North America. Here's where we're notifying FEMA, just in case this escalates to even worse, possibly the White House Situation Room. Here we most certainly are at that point, and we're doing all sorts of other reporting. So for here in Colorado, just as a quick note now before I forget about it, if you start paying attention to our forecast and these things, we start talking about a G3 level storm, it might be time to look for the aurora here in northern Colorado. You can see it at lower levels even, just depends. There's all sorts of things that go into that. But G3 is a pretty safe bet to take the time to think about looking for it. So we put out alerts, watches, and warnings. Now the Weather Service as a whole puts out watches and warnings, and you should all be intimately familiar with what a watch means and what a warning means when it comes to severe storms, blizzards, and so on. So we do the same thing in space weather. We put watches out for geomagnetic storms 1 to 3 days in advance. Warnings when it's about imminent, meaning it's about ready to happen or begin. And then we put out something called an alert. An alert means that a level's been reached. We do that for every single category that we send alerts out for. Why? Because the customers and users of our information want to know. They need to know about it. We will make phone calls for watches. We will make phone calls to customers for warnings. And we will make phone calls to customers for alerts. So we get really busy in the forecast office making a lot of phone calls. So when we have the R scale, that is related to something called solar flare. A solar flare is what you're seeing here, these electromagnetic blasts of energy that we measure as an X-ray, so we have to use a satellite in space to measure their intensity. But they can be instantly disruptive on the daylit side of Earth. So here's something a lot of people get confused about. They all understand the speed of light and they think they realize it takes 8 minutes to get here. But what's often forgotten is we see it, the effect is already here. It's already made its 8-minute journey here to Earth. So on the daylight side of Earth, we're already going to experience high-frequency radio problems when we start to get into those 1 through 5 categories on that scale. This is only going to impact sunlit side of Earth, however. Who cares about that still? Well, ham radio operators. Aviation still cares about it because they use high-frequency radio when they're flying across the oceans. Flights flying near the polar regions use it, and some emergency responders will use it still to this day as well. So there's still a big interest and need to know when it comes to these events. You can go on our webpage. I know this is kind of hard to see right now, and you can watch the X-ray flux for yourself and see when these solar flares are taking place and kind of have an idea. Oh, gee, I wonder what else is coming, if anything else might be coming. Now here's the scary thing when it comes to today. And this is a good point about activity happening as you're coming down from solar max. So solar cycle 24, the one previous to the one we're in now, peaked around, I forget, 2014 or 2015. Well, 2017, 2 to 3 years later, we had the largest solar flare that we've seen that entire solar cycle. It became very disruptive. This red area you see here is where high-frequency radio communication became impossible. It became very difficult in the other sets of colors here. What was going on in September of 2017? A very active hurricane season across the Caribbean. Hurricanes like Irma had created a swath of destruction across the Caribbean islands. FEMA was deployed out to those islands, and how were they communicating? With no power, they were using their high-frequency radio systems. They couldn't communicate. Solar flares usually last just minutes to tens of minutes. They're very impulsive. But sometimes you can get a long duration event, and they can last hours. What exacerbated this? This was a long duration flare. It lasted a few hours. So this was very disruptive to aviation and even emergency responders trying to do their work because there's no electric power and they couldn't even communicate properly as well. So think about that in today's world. What do we have here a lot about today? Long duration and a lot more heat waves going on in areas of the country. Artificial intelligence and these massive servers that pull a lot of power. So you take a major heat wave in an area of the country today, that's stressing the electric power grid tremendously as it is. Now you take these AI big data centers, you add to that pull and stress, that's a major problem that the government cares about greatly right now. Now you throw in a Carrington event. Oh my gosh. That is probably very problematic and very quite worrisome. That's why it's going to be on the National Risk Register, and that's why we all should care and have a general understanding of space weather. So when you hear about all this, you're not among the crowd that says, I don't believe what I'm hearing. This has got to be somebody doing a cyber attack, or this has got to be a rogue terrorist group over here. No, it could very well be the sun doing its thing.
Solar alert, solar alert.
Oh, yeah, Amber Alert.
It came through.
Figures during a talk. Why is this coming on my phone? Oh, I can't stop it now. All right, so anyway, so that's what they're worried about today. You take all these events and you put them together. Now, space weather can do its thing on its own, but you add all that other stuff into the mix, and there you have a problem. 1967, you remember that? The radars looking like they were getting jammed? Guess what? We had something like that happen again, much more recently. 2023, in December, near Christmas, aviation almost came to a standstill across the country. You do not know about this. Why? What happened? The sun let loose one of these radio burst bombs, as I like to call it. Yeah, nobody else is going to get it. It figures during a talk, right? Where else would an Amber Alert suddenly happen? So what happened is this solar flare right here should have just disrupted high-frequency radio communication. And it did to a minor level. It wasn't all that big of a deal. But what else did the sun do associated with that? It let loose this giant radio burst across a huge level and swath of the radio spectrum that we measure. And in this case, it was really focused on line-of-sight frequencies, what we call VHF and UHF freaks. Who uses those? Aviation flying across the domestic United States. They use those line-of-sight systems to talk to air traffic control. All of a sudden, they couldn't do it. Pilots are pressing their mics, and there's nothing. It's like somebody's got their finger on that frequency pushed down already. And they couldn't find a frequency that actually worked. This problem extended all the way from the eastern part of the U.S. all the way to the upper northwest. Seattle, it was so bad, that they almost declared ATC 0. If you don't know what that means, all you need to know is the last time that was declared was the 9/11 terrorist attacks in 2001. That is shutting down airspace. Across the country in that case, here Seattle was going to shut down airspace. We got the word out, just like Dewey's father did, about this being a space weather event, a radio burst, and they understood it was going to be not a long-lasting problem. Usually they don't last beyond 10 minutes. But it affected other systems too, to include radars, because of the frequencies that this impacted. We don't want to see that happen today. Imagine if the weather were bad that day in New York City or some busy airport like Denver, and all of a sudden they can't communicate? That's kind of frightening. So we need to care and understand more about space weather. What's bad? We can't forecast a radio burst. We can forecast solar flares, but we have no idea that a radio burst is going to happen. But thanks to the Air Force and Space Forces, they still staff this radio telescope network, and that's how we find out about things like this. So that is never going to go away. Solar radiation storms. These are caused by things called solar energetic proton events. So now you kind of get into atoms and think electrons and protons and neutrons. What do these affect? These can cause damage to satellites in space, especially at high orbits like geosynchronous satellites, geostationary satellites. Low Earth orbiting satellites are generally not affected by these events because they're deep into the protective magnetic barrier, where the other ones are kind of outside of that protection. But we measure these on our scale. The largest storm that we've seen was one that reached the S4. That means when there's usually less than one of these protons in space, we hit over 10,000 of them in one little tiny area of space on the sensor that we use to measure them. And S4 is a pretty significant event. That's definitely warrants the word severe. That was in January of 2026. These storms also affect astronauts. We talk to NASA, by the way, every single day because of the astronauts living on the space station, and talk about these events and other events that they care about that could affect them. Solar ray storms, once again, on our webpage, you can go in there and learn how to look at the scale yourself and kind of see when these storms are going on. When these happen, they tend to last a while. Flares, remember I told you, last tens of minutes to maybe hours at their longest. These can last days until they trickle down back to normal. One of the largest solar radiation storms we saw, we kind of got lucky here at Earth. We didn't experience it. It went to Mars. It went to the planet Mars, and because of the Mars rover that was there, it has a sensor that was able to measure it. And if this had come here to Earth and we had, let's say, the Artemis II astronauts in space, this storm would have provided about the equivalent of 30 chest x-rays. Bing, just like that. That's why we supported Artemis II when it went up. That's why we had a forecaster at Houston Mission Control from SWPC providing direct decision support for the health of the astronauts in case something like this happened. They get immediate word. Our number one priority is the power grid. That's the first call we make when we hit that level. When Artemis II was going up, because now it's human safety, that was our first phone call. All right, so let's get into coronal mass ejections, or CME for short. That's what these can look like at their most dramatic. Think about how sizable the sun is. That is a huge chunk of solar material that just flicked off the sun. What causes that? Well, these magnetism. Just like sunspots form from magnetic fields that have become complex, magnetic energy holds a lot of solar plasma in place. And sometimes that material has to give way due to magnetic stresses going on. This is what we call a filament eruption. Who's got a hydrogen alpha telescope in here? Like a Coronado or something. Yeah, okay. You can actually see this happen for yourself if you happen to catch it at the right time, because this takes a while for this to happen. You could actually track it yourself if one of these was going on, because it's not seconds that happens. It takes minutes to hours before you see it leave. But what do these things look like in coronagraph imagery? Well, they look like this. Poof. Size of the sun, the white circle here. Black circle is the false moon, if you will, the occulting disk, so we can look at the outer corona. These CMEs are huge. They propagate and they expand as they move out into space. This kaleidoscope of colors here is the model that we use to help us figure out whether or not they're going to hit Earth, and if so, when that might be. They do nothing to tell us about intensity. That just comes from our forecasters' experience and minds. But these coronagraphs in space are critical to us. Did you know that until about, what, a year and a half ago or so, 2 years ago, we had one coronagraph in space taking all these pictures? It's an old NASA research satellite that's like 2 decades old. It's on the point of failure. Fortunately, we got another chronograph in space, and that's GOES 19, has a compact chronograph on it. That's a NOAA operational satellite, meaning NASA can't stop tracking it and move on. We had a problem looking for these CMEs even when we were getting information, because what NASA could do is say, all right, we got to take the tracking off that chronograph and go over to this probe that's looking at an asteroid. And we could see no imagery for hours. That Carrington level event got here in 18 hours. We think the fastest they can get here is 15 hours. Have we had gaps that long? Yes, we have. But now, thanks to C-Core 1 being on GOES 19, that won't happen now, because we're getting pictures every 15 minutes. And then Solar 1, our new solar wind observatory, a million miles from space where this chronograph has been, has a C-Core 2 instrument on it. So we're going to eventually make that public, and you'll all see that imagery. So we should be able to have continuous observations of the sun, thank goodness, looking for these CMEs. What happens when they get here? Well, they create something called the geomagnetic storm, a giant magnetic disturbance. So here's how the series of events happens with these events. Using chronograph imagery, we detect and we examine the CMEs. So let me give you a little comparison here. Think me being a weather guy, I'm looking at a thunderstorm, I'm standing out on my porch and I'm looking at a thunderstorm cloud develop. And I say, oh, based off that anvil, based off the Mama Odyssey I'm seeing here, based off this, okay, we're going to see an F2 tornado at 7 o'clock, and we're going to see hail 2 inches in diameter at 6 o'clock. Nobody can do that. That's what we're trying to do here. We look at a CME, we look at the shape, we measure that shape, we put it into a supercomputer, and we try to get a result. That's visual analysis alone. That is what we put our watches based off of. We know nothing about the magnetic strength. We do not know the true speed. We don't know the magnetic polarity of that thing at all. It's our best scientific guess that we put out there for a watch. We don't know what it's actually going to look like until it gets 1 million miles from Earth, so it's already traveled 92 million miles, and it gets to our observatory, Solar 1 now, brand new spacecraft, thank goodness. It's getting great data right now. You can all see it for yourself on our webpage now. And that's where we see it. So that would be our warning point. We see it there. Now we know it's minutes away. We can issue a warning, because we have to understand the magnetic intensity, its orientation, the speed, and all that stuff to be able to put a proper warning out. And then as it hits and envelops itself around Earth, we use a fleet of magnetometers, these surface-based observation equipment that measure changes in Earth's magnetic field. We have these around the planet, shared information from other countries, the military, and here with the USGS in this country, and we can get a general idea of the magnetic disturbance level and thus know how strong the geomagnetic storm actually is. A lot of information on this slide, but when we forecast geomagnetic activity, we forecast something called the KP index. It's a 0 through 9 index. 0 through 4 is not NOAA space weather scale. When do we put out our first warning? KP of 4. Because there's precision engineering people out there that need to know about that, because it can affect their equipment. Pigeon racers. Do you guys know that pigeon racing is a big thing still? It's like a multi-million-dollar business. Those things migrate, those homing pigeons migrate based off magnetic fields. So when we get to just like a KP of 3, well below the G1, we sometimes get phone calls from them asking what's going on, how long it's going to last, because then they won't fly their pigeons because they could get lost. Who would have figured, right? But anyway, we get to KP of 5, and all of a sudden we're up to G1 level. That's where the cross begins. And know also that these are all broken down into 3s, with the exception of the top one. So you can have like a 1M, a 1Z, and a 1P, and then 2M, and so on. And the reason that's important is KP of 5, all 3 levels equates to G1. It does the same thing through all of them until you get to KP of 8, the G4 level. KP of 8 through KP of 9M is actually a G4. The top end, the index, KP of 9Z, that's the top, that's a G5. So you can have a G5 that's here, or you can have a G5 that's 3 stories above my head like the Carrington event. We don't have a way to measure that difference just yet, but we're learning and we're now developing something so we can convey just how strong something is getting. The storm we had in May of 2024, anybody see the aurora in May of 2024? That was the first G5 storm we've had in 20 years. That's how rare these can be. And that was a G5 that was here. Was there problems? Yes, there was, and you're going to hear about it tonight. So, what do we do for the power grid? Well, I've kind of talked about this already. We're already making phone calls to Wisconsin and the New York Independent System Operator, transmission operation centers at the lower levels. Are they going to experience a major power outage? No, but it's going to affect their systems, and they want to know about it. Hotline call happens here. FEMA gets notified as well here. And if we haven't been talking to the White House already, we are at G5. How many times have we hit G4 to G5 this year? 1, 2, 3, 4, 5 times already. Almost to 6 very recently. But now we're doing something else for the power grid. This is the last thing I'll talk about for the power grid here. The May of 2024 storms, up until then, we've only been calling the power grid when we're putting out a warning for a G3, meaning it's minutes away. That's not a lot of time for them to do things to prepare the power grid. This takes hours to days of preparation to do the things to really protect the grid with those storms. Well, in May of 2024, I got an inkling to call the power grid folks we talked to and say, hey, look, we put out a G4 grader watch. We think there's a chance for a G5 here based off what we're seeing. What do you think about doing this early hotline call now? And they said, man, that is a great idea. Please do it. So that ended up giving them 6 hours of lead time. From the time I finished that phone call to the time the CMEs arrived here was 6 hours. And they were able to do things to help protect the grid, and I'll explain those when we talk about the effect from that storm. Because what these do is they cause geomagnetic induced currents. Think of a free electricity showing up in the lines. The problem is it's the wrong current, it's DC, and it harms their systems if they don't account for it. It burns up transformers. So we provide detailed information about how strong these GICs might get, and this is really only useful to the power grid. And they really want this, and we're going to do our best to give them more regionalized, tailored information. Because all we provide right now is a planetary KP warning. It does nothing to tell New York ISO exactly what they might get. That's where we want to get to, is regionalized information for the power grid. We've got international collaboration going on when it comes to space weather. We used to be the only people doing this. Space Environment Center, whatever it was called prior to then. But now the rest of the world is doing this. We have a very tight relationship with the United Kingdom's Meteorological Office and the Bureau of Meteorology in Australia, because they all have space weather offices. They all care about their needs for space weather. They have satellites in space. They have electric power systems. So we're all coordinating now. We actually communicate on a daily basis with those two partners in particular, along with the Air Force and Space Forces and NASA, when it comes to these storms. So that we're all on the same page of what we're expecting. We can't have the UK Met Office in England saying we're going to get a G5 and we're saying, no, this is just a G1. In a planetary interconnected world, we can't do that. We have to be in agreement. New platform, Solar One, I've talked about it. Magnificent. Years in the making. I'm so glad it's out there because it's an upgrade that was needed so badly. The other instrument was failing and really kind of disgraceful from the beginning, honestly, because it was putting space weather was a last minute thought. Remember the Deep Space Climate Observatory, taking pictures from Earth to space for climatological studies? Great idea, great thing. The problem is they used that to share a ride and thrust a space weather package on there. And that space weather package did not do well. This one is dedicated only to space weather. So we are getting really good information now. The European Space Agency is working with us here at NOAA for a mission going out to L5. What that means is right now, we don't have a picture there of that, but right now all these platforms that are 1 million miles from Earth are what that's called the Lagrange point 1. It's kind of a, think of it like a balance in gravity. That's not really what's going on here between the Earth and the Sun. That's kind of what it's like. It makes it easier for the engineers to keep a spacecraft in that location. So it's always between the Sun and the Earth as the Earth revolves around the Sun. L5 is about a 45-degree angle or so from the Sun behind Earth's orbit. So it'll give us a side view of the Sun and what's not only going to rotate in Earth view eventually, but as the CME blasts up the Sun, now we'll know for sure we're headed toward Earth or not. It's very difficult to do that on a direct line of sight. You can't really tell. But you put another one over here, man, you can get a great trajectory on that, and that's going to be huge. That might be available sometime after the next solar maximum. And then even Korea's involved with us working on a mission that might go out to L4, which is 45 degrees ahead of Earth. You may wonder, why do we care about that? Well, we're going back to Mars. We intend to put people on Mars sometime in the next 20 years or so, so we do need to know what's going on ahead. So what might happen if a Carrington event unfolded today? Well, these hours of time would have been a lot longer than what you see now if it hadn't been for C-Core 1 on GOES 19. So now we could probably detect and realize that a fast CME is headed towards Earth within 1 to 3 hours, where that might have been anywhere from 6 to 15 hours prior to C-Core 1. 2 to 4 hours, we'll get some initial analysis in. We can start advertising that we got concerns about a Carrington level event here. 2 to 6 hours, we'll collaborate with everybody else and start to come to some kind of consensus. Within 4 to 8 hours, we'll get that G4 or greater watch put out. We don't do a G5 watch. We stop at G4 or greater. We'll get our messaging going. Bottom line, we should get plenty of notification out there about that potential of that event. Here's what we care about. So these geomagnetic induced currents for the power grid. Now here I'm going to frighten you a little bit. So we usually measure this in millivolts. So 1 over 1,000, 1/1000th of a volt. So 67 millivolts, 142 millivolts, whatever, are usually what show up with a lot of these lower level storms. When you get just 1 volt per kilometer, the power grid's noticing it. So it causes a problem? Not necessarily, but they're noticing it and they may start to take some protective measures to prevent harm to their equipment. You get to 10 volts per kilometer, they're dealing with the problem. Are they going to overcome it? Probably, but they are dealing with the situation. You get to 12 volts per kilometer, it could cause a collapse somewhere, potentially. 14 to 15 volts per kilometer, they might not be able to handle that. Why is that important? I'll show you later on what the May 2024 storm got to and what 1989 was, and what the Carrington event might look like. Oh, what I'm showing you here, these circled areas, those are the most prone areas of our country for a problem with GICs. This whole Appalachian chain, major population in the country. Upper Midwest, probably the most impacted by an event. Upper Northwest, not just because they're further north magnetically, but their geology is conducive to causing these currents to form on their systems more than other locations. And Texas is not immune. This area was just not surveyed yet. It has now, and we've come to realize that Texas could be impacted more than we thought they could. What might unfold? Well, the power grid. There could be a major collapse in the system affecting millions and millions of people across many states for days to weeks on end. Satellites. This is just an idea of the low Earth orbiting satellite population, and it's growing, and it's growing, and it's growing. And these are with a storm like that, they could deorbit, burn up in the atmosphere due to problems from these storms. They could collide with each other, which would be even worse, spreading debris fields out there. Space launches could get postponed. In some cases, that could cost millions and millions of dollars, especially if it's something very important. Farmers. I'll talk about this more, but I had no idea how reliant farmers were on today with GPS. And now farmers have to be space weather ready. Who would have figured, right? And that's where we're going. The Gannon storm. This is the May of 2024 storm, the spectacular aurora that lit up the world. Kind of a Carrington level event, almost aurora sighting, although it wasn't a Carrington level event as far as its impacts go. But look at aviation. Here's a sampling of transatlantic flights, the normal flight path. Look how much further south they flew. That's a lot more fuel, it's a lot more flight hours, that's causing delays, changes in the scheduling, more and more. Why did they do that? Because of the high frequency radio communication became almost impossible from time to time due to the length of the storm. These are measured every 3 hours. We hit G4, look at that, G5, G4, G5, this thing went on for 36 hours. This was 7 CMEs all catching up with each other and flowing over Earth. That's what made this very dramatic. True story. My brother-in-law in North Dakota, I'm from North Dakota, grew up there, went to school there before I joined the Air Force. He called me. Now I'm used to getting teased as a weather guy about regular weather. Hey Shawn, how come you didn't tell me about the hailstorm? Hey Shawn, it must be great getting paid to be wrong. All the great meteorology jokes I've suffered through my entire life. Well, this is the first time he called me with a space weather storm report. And it wasn't about the aurora. He said, hey Shawn, what's going on with my GPS? It ain't working. So for one, he's calling me. He must have already had an idea what was going on. And he did. I said, well, it's the geomagnetic storm. He said, uh-huh. So he was out there trying to plant his seeds in May. Rare break in the weather. It's supposed to be accurate within centimeters. It was off by 12 feet. It was taking his tractor in turns he couldn't even accomplish. That was storm report number 1. Hundreds and hundreds of storm reports later, we come to find out that farmers across a lot of the United States were experiencing the same problem. John Deere had an issue a statement, kind of a space weather bulletin statement about, hey, space weather, it's affecting our systems. It may not work for you. Well, I wish you had told me that 3 hours ago before I got into a big fight with my colleague over here, or before I started tearing my equipment apart trying to repair it. Space weather. It should be showing up on news broadcasts to help with that messaging so people understand what they might experience. The largest satellite migration in history happened during that storm. 5,000 satellites were burning fuel at the same time trying to correct their orbit because they were trying to deorbit because of the space weather storm going on. So they're burning fuel to keep them up there. They didn't know where your satellite was or where your satellite is. They're using math, hoping they're right. But the storm is throwing that equation out the window. Collision avoidance is becoming a major concern today. There's an Office of Space Commerce in Boulder, just down the hall from us, and that's their job, is to deal with collision avoidance issues. We do the forecast, they take that information and translate it into their models to help them with that. So this is just a sampling of some of the things that happened with the space weather storm in 2024. Did we experience a major malfunction here at Earth? In the US for the power grid? No, we didn't, but there was a power outage up in Idaho, Washington. A high voltage capacitor of many, one of many, tripped out up there, and it happened to be about 2,000 customers lost power. Was that due to the storm? The capacitor trip definitely was. They've confirmed that. The related power outage? Possibly. That's the one I'm talking about, right there. Covered a pretty expansive area, lower population out there, less people impacted. But space weather does impact us. We have to understand that and realize that and know that. These are all the different grid problems that happen. Most of it was preventative measures due to the early word we gave them. What they were able to do with hours of notice is they could get a high voltage transformer ready to take on a load that they can't do in minutes, but they can do it with hours. They could get high voltage transmission lines ready to take on additional electrical current that they can't do with minutes, but they can do it with hours of notice. They did all those things. It cost them a lot of money to get ready for that storm. But in situations like this, they put customer needs ahead of commerce. Kind of a rare thing to happen in today's world, right? But they do it for things like this. We try to provide tailored information, some of it very simplistic looking, but we want to get down to the level we can provide different sectors, satellites, power grid, aviation, exactly the information they need in exactly the language they need. So we've got a lot of work to do here because we're used to talking science and jargon. We want to let them know exactly what the effect is that they might get. All right, so let's compare a few things as we start to work towards wrapping this up. There's something called the Disturbance Storm Index. I won't describe what it is. If you take your time, you can read what it is here. But what that is the larger that negative number, the more strong that storm. 2024 got to a very respectable minus 412. That is a severe storm. 1989 got to a minus 589. That is much stronger than what we experienced in May. That knocked the power out in 90 seconds in the province of Quebec, Canada. The 2003 Halloween storm is much more impactful, but a little less DST, but very equitable. Why was it much more impactful? Because we weren't as space weather ready as we are today. We do things now we can forecast better. The 1921 railroad storm, twice as strong. That's kind of frightening in today's world. The Carrington event is estimated to be at least 3 times stronger. That is what we got to be prepared for. So what can we say about that May of 2024 storm? The spectacular won over the consequential. The world got to experience the aurora, and unless you were a farmer or an aviator or the power grid operator sweating the storm out trying to deal with the problem, general public, you got to experience the event of a lifetime if you were able to see the aurora. Why? Because it was the most successfully prepared for and mitigated storm in space weather history. Because we've learned so much more, we provide the early notices, we talk directly to these customers, things that weren't done in 2003 or years before that. That was the last time we had a G5 storm. It was 2003. All right, so one of the things I wanted to highlight to you, all of you aurora watchers out there, is pay attention to the solar wind. You can find this, as I said, right on our webpage and see for yourself. Because here's what's important to know, especially if you're an aurora enthusiast, is magnetic field Orientation makes all the difference. I told you we put the watch out based off visual alone. We put the warning out based off changes we see in the solar wind. But here's what's key. If you look at our solar wind, on the page, it might be in a different background color, but if you look at the top plot, the one called BT is the magnetic field strength. In this case, it's the white line. Normally that's at 5 nanotesla. Don't worry about what nanotesla means, just remember the number 5. Background is kind of at 5. You get to 10, that's a respectable twice as strong. And yes, that can cause G1 storming. You get to a 20, that's 4 times as strong, right? And so on. The red line in this case, what we call BZ, might show up a different color on for you. That's the orientation. So this is why these little thumbs up and thumbs down are important. So if you think of Earth's magnetic field, it's thumbs up. Comes out the South Pole, goes into the North Pole. Orientated north. Along comes the CME. If it's orientated the same way as Earth, it's going to collide with our magnetic barrier, the magnetosphere, cause some things to happen. We may see a brief storm, but then nothing's really going to happen. But if it turns south or arrives south, now you're connecting negative and positive energy together, and that escalates things. So look how this works. Here's a little jump, twice as strong. A CME shock arrives here at Earth. Not very strong shock, but nevertheless it was quite evident. But look at that red line, that BZ, that orientation. It's kind of neutral to north, same as Earth's. Look down here, we hit G1 levels, and then back down below, the green is below G1. But then what happened? Look at the magnetic field orientation. It went south, negative. That's when all that escalated. The magnetic field strength also got much higher, 5 times stronger, 6 times stronger, but it's all southward. We're connected. And then look what happened. The magnetic field strength was still strong, but the magnetic field turned back north. And look, down with the geomagnetic response. That's the problem we have. We never know what BZ is going to be until we see it at the satellite. But you, wanting to see the aurora, if you start to monitor that for yourself, you can say, whoa, hey, things are getting favorable. It's time to go out and look for the aurora, right? That's why it's really good for you to know that. We'll be busy in there dealing with the sectors, needing this information, trying to talk them through what's going on. Meanwhile, you can follow that for yourself and know when to take that drive out of the forest to go see the aurora. Last storm I'll talk about before I get into the big effects here. Look at how strong this one was. We have a chief scientist at SWPC, Dr. Howard Singer. He's been there over 30 years. He's never seen a CME this strong in his professional career. We had a CME arrive in January of this year, Martin Luther King Day. My holiday got to be spent at SWPC working through the storm. So what happened? A CME arrived, we were expecting it, we had a G4 or greater watch out. It came, that got to almost 100 nanotesla. My gosh, that's 20 times stronger than normal. That's huge. Look at that magnetic field. When it arrived, it went south immediately. Boom, we shot up to G4, almost to G5. And then it quickly turned and went north. That's why the world didn't see the aurora. That's why we didn't experience anything in this country, is it went sharply north and it stayed there. But even at that level of strength, we were still hitting G2 levels. That's pretty amazing. And then it turned south and we shot back up to G4, even though the field strength had come way down. See how that works? And we lasted that way for quite a while. What was important about this storm? Southeastern Australia got dinged. Their electric power grid went offline during this. They were affected by that. Over 8,000 customers lost power when 4 high voltage capacitors all went off at the same time because of these geomagnetic induced currents that showed up on their systems. They got power back up within a number of hours, but still, if that had lasted all the way through here, I'm concerned about what might have happened in the rest of the world as well as in this country. So recent storms, the Veterans Day storms, my day, Cindy's day, one of those days that space weather happens again because it's a holiday. 30 flights canceled because we had the most intense solar radiation storm that we've seen in years happen. Flights flat out canceled because they were going to fly near the poles and they could have been exposed to these solar radiation particles. The Blue Origin escapade launch, the Mars mission, got scrubbed 24 hours because of that same energetic radiation storm. They realized they couldn't fly into that without causing probably a failure in the spacecraft electronics, so they scrubbed it. NASA was calling myself and one of our other PhDs over there a lot that day because they were freaking out. They had the pressure on them to launch, and we all experienced this weather, guys. Pilots always want to be able to fly. They always want the weather they want to hear about. We couldn't give it to them, so in the event they finally scrubbed it, which was really the right thing to do. A lot of more GPS problems reported. The Martin Luther King Day storm, I talked about the power outage, but look at this. I told you I didn't realize how reliant farmers were on GPS. I didn't realize we had a bunch of GPS approach airports out there. Only GPS approach. Aspen is one of them from time to time. Flights were diverting from Idaho all the way down to Texas because they were trying to land at small GPS approach airports only and their systems wouldn't work. That's costly. You're a passenger, that affects you, right? You end up in Omaha, Nebraska instead of in Aspen, Colorado. That's no fun, right? So here you go. That's why we care about space weather. So SWPC, our decision support, continues to evolve. We're involved with the international aviation community when it comes to space weather. We send out advisories now, specifically for the aviation community. I've talked about other missions that are out there going on. Solar One, IMAP is a NASA research mission, but it's kind of our backup solar wind system now. It's also out there, so we have great information now. C-Core 2, more coronagraph imagery is coming. I thought it was going to be here in July. It might be still a little bit longer delayed, but it's coming. Emergency managers across the country. These are just talks that I've given to emergency managers. Getting space weather ready, smarter about it, wanting to put in their hazard risk assessment plans to think about it. Colorado's in there, yay. California, gets a boo. Just Los Angeles there, 6-7 minutes. My wife's from California, I have to tease her. So yeah, we continue to educate space weather folks. They're doing exercises when it comes to departmental level exercises when it comes to space weather. We're getting ready for this as much as possible. How do you stay informed? You go to our webpage, spaceweather.gov. You can subscribe to product subscription services and get a lot of these alerts, warnings, and watches and forecasts via email. Learn how to read our 3-day forecast. It goes out twice a day, along with a forecast discussion product, so you can read more details about what's going on. Learn how to interpret them. Learn how to look for yourself of when, oh, it's time for me maybe to look at the solar wind for myself and see if something's arrived here. So that is what I have to talk about. The last thing I'll bring up is we're doing our best to upgrade. We're trying to get on social media more. So we have Facebook, we have X, and now we're on YouTube, and we do space weather videos now. Right now it's mainly me doing them. So if you look up Shawn Dahl space weather, you're probably going to find me doing some kind of video out there. Because we want to communicate directly to you, directly to aviation, directly to everybody, and give them the idea of what's going on. I just walk and stand around the forecast office showing what I'm seeing and I talk about it. We want to do that because that offsets the press and the media. People like Leonard don't come calling me every time something's going on. They've learned. They know what a CME is now. I don't have to explain it over and over, and that's what these videos help to do. The goal is to be able to do this from event onset, get out there, do a quick video update, continue our social media updates, give event updates as activity is progressing so that you all stay informed. You all begin to know, is this the event I need to care about and worry about or not? Or is it just time to look for the aurora? So you'll see more and more of these as I train others to get more comfortable talking to the public to get out there on video. So I'll wrap up with this. I was asked to do this. You saw some pictures earlier. Yes, you can do space weather from your own backyard. This is a picture from one of my small telescopes, just using a regular filter to look at sunspots in the sun. This came out really nice, actually. I'm pretty happy with this. Picture of the full moon, right there from the backyard. Other space weather pictures. You guys all have better stuff than this for me. This is me with a DSLR camera in my backyard. But yeah, enjoy your hobby, clear skies, and if you got any questions about space weather, come talk to me. This is my big Milky Way picture. Where's Milky Way rainbow out over New Mexico? Cindy was patient enough to stand out with me in the middle of nowhere, the Bitsy Badlands of northwestern New Mexico. Little buttes here in the distance, and I had a fisheye lens on there, and I took lots of pictures. And then I got this nice, beautiful rainbow Milky Way. So I'm pretty proud of that one. That's all I have for you. Hopefully you learned.
Questions?
Any questions? Yes, sir.
Is there a theoretical limit to how bad an event can be?
No. Our sun, we don't think is capable of producing something you might have heard about, a super flare. We don't think is really capable of doing that, but we don't know for sure. There's historical events that could perhaps be stronger than the Carrington event. Maybe you heard of things like the Miyake event. This is something they discovered with tree rings from centuries ago that suggest that maybe there was a storm that was very much stronger than a Carrington level event. But right now, Carrington's the largest that we can really conceive of, and that's what we're basing everything on.
Putting you on the spot here a little bit, if you could recommend one or two things that you would say that the government or industry do to prepare for space weather, what would they be?
Understand it, absolutely number one, and that takes a lot of time to understand it. Some of you are probably overwhelmed with some of the things I was talking about tonight. And number two is take it serious. Yes, it's a very uncommon hazard. Yes, it is unlikely, but by God, when it happens, we've got to be ready for it. And that's point number three. Be space weather ready for the thing. And fortunately, they are. They consider it a major risk. I mean, showing up in the National Risk Register is not, it's a pretty big deal. So to have that in there, that's taking care of those three things and allows me to do what I'm doing with even you, which is education outreach to help the nation be more space weather ready.
So the grid operators, what are the main things they do when they need to do something?
I don't know precisely what they do, and there's a lot of reasons for that. For number one, just like the satellite community, they're very hesitant to share information. There's a lot of reasons for that. Legal reasons, liability reasons. The one thing I know is they like to use a term called conservative measures, or precautionary measures as well. And usually what that involves is spinning up procedures, spinning up manpower to have them go check out the integrity of the transformers, actually listen. One of them told me they actually have the technicians listen to see if there's any change. You know, like Scotty on Star Trek, he just had a knack for understanding things. Same with some of these technicians. They can listen and understand changes in the transformer functionality. They are very unlikely to ever do something as extreme as we're doing a lot more here in Colorado, which is just shutting down areas of grid during a high windstorm. They're very unlikely to do that because they're pretty certain they can weather a space weather storm. Can they? If there's other things incorporated, I don't know. So the biggest steps they'll take, the most costly, is like they did with the Gannon storm, and I think with some other ones since then, and that's get these transformers that aren't being used up and spun up and ready to deflect some of that energy if one's starting to overheat, or those high voltage transmission lines actually taking on extra loads to help spread out the current, if you will, to help prevent some of those GICs from being too harmful on just one line. And that all takes steps and actions, more manpower to do it and keep track of it. So that's what I think the things that fall under that. Conservative measures might be things like also spreading out. I don't remember the word that I heard, but basically think of it like if there's a heat wave going on and the grid is already stressed, they're going to do things to help spread out that load. And now comes space weather, they're absolutely going to do that. I don't know all the engineering techniques of what they do. I'm hoping to learn more because guess what? In the end of August, for the final 2 weeks of August, we're getting the power grid industry to SWPC down in Boulder, and they're going to be in a room with us, and it's with the electric power grid. These engineers are going to come together, and I'm hoping to learn more about what exactly they do because we need to know what they want, and to do that, we need to understand what it is that they do, actionable steps that they take. So that's a major event that's going to happen here at SWPC, and we're going to learn a lot. And that was just focused on the power grid.
Is there an actual correlation between active sun and earthquakes?
Unknown to me. I do know of all the talk. There's actual valid scientific studies going on about it. Do I know of any correlation? No, I do not. Does it mean it's not there? I don't know. I'm not an expert on it. I have no idea. But I am well aware of people finding what they think are connections there. I'm also well aware of people that are susceptible to migraines. I've heard a lot of reports about people's migraine headaches materializing. I'm not saying it happens or doesn't happen, but am I one to judge people on what they think? No, I'm not. I'm not a health expert either, so I don't know. But there are studies like that are ongoing. Yep.
For speed of CMEs, light gets here within about 8 minutes. how, did you say it's up to 30 hours that it, what's the time for?
Yeah. So I'll take a step backwards. Solar flare, speed of light, as you talked about. We see it, the effect's already here. It's about an 8-minute journey, so we can't warn on it because it's already here. Solar proton event, the radiation storms, they can be almost speed of light, but not quite. So we have a little warning time there, that's why we can put out a warning. They can get here as fast as tens of minutes, those particles, to hours later, many hours later. A geomagnetic storm, the CME that causes that, fastest we think they can get here is 15 hours. But usually it's 2 to 4 days. The CME we saw in January, that got here in like 24 hours.
So that's why when the satellites see it, they can send us the information really fast, and then we know, have a lot of time, more time to see it.
Right, the satellites that are out there that have the chronograph on it, yeah, we can see the CME take place, and that's where we try to determine the speed, but we won't know the true speed until it actually arrives 1,000,000 miles away. Other satellites, as the CME arrives and are taking pictures of the CME in progress, at some point it's going to wash out, they won't see it anymore, because it's become so big it's outside the field of view, but it's still moving through space. And then we don't see it again until we actually see the visual evidence on the observations.
So AI, how do you use it, and how do you see it being used in the future?
Right now we aren't using it at all, except for reports, to help us out with reports and administrative functions. But yes, we are beginning to explore AI in the science field, and eventually as that, what we call it research to operations and operational needs back to research, R2O. R2O is going to start to give us some ideas of how we could use AI, and then we'll determine how best to utilize it. But yes, there's no stopping AI. It's going to come in. Is it ever going to place a forecaster? Not in the near future by any stretch, because there's still too many unknowns. AI has to have a lot of knowns to be useful. And space weather, unfortunately, just has a lot of unknowns.
Hey, when you have a new spacecraft that's providing, you mentioned one of them, how difficult or easy is it to integrate with the other data you're getting there? And is it possible you're going to get conflicting data coming out of these different satellites that they don't line up somehow? Or I don't know, you know. I know you want more data, but can it be confusing at times?
Not to me, and the only reason for that is we got great engineers and great IT specialists and data workers that put all that together. But yes, there is a lot of work that goes into something like Solar One, from the onset, not only from the visualization of it and then the construction of it, the engineering to launch it, to get where it needs to go, but the work involved in getting the tracking stations to commit to tracking the thing across the planet. The work that's involved with making sure the systems and observations on it, it has to go through a number of, I forget what the term is, but consider it like accuracy tests. How reliable is the data? So we went through months of that with Solar One, step by step by step, before we decided, hey, what? This proton sensor on here is now good to go. And then the solar wind information is good to go. We're waiting for that for C-Core 2, but eventually that'll be there. But we didn't want to wait, so we've got the other information out there. But yes, could there be a disparity between what that's seeing and what the old spacecraft ACE or Discover is seeing? Well, Discover got shut off. We don't even see that anymore. But ACE is still out there. Yes, there can be subtle differences, but not as much as one would think. They're usually very much in alignment.
So these are the natural solar phenomena with their effects, potential effects. But then there's also EMP.
Mm-hmm. Yeah, EMP, you don't know what that is? That's electromagnetic pulse. Think of a nuclear explosion going off. That can destroy your car's battery and electronics at your house, like, well, you're going to burn alive, right? But I mean, your equipment's also going to be destroyed. But that's not what geomagnetic storms are. A geomagnetic storm induces something called a GIC, geomagnetic induced current. That's different. That's not going to affect electronics at your house directly like that, not the high voltage stuff. That's only on the high voltage transmission lines, which can affect the transformers that you all rely upon, but not the small transformer going to your house. That would be stopped by the high voltage transformer stopping it. So EMPs are a separate thing. GICs are what we're dealing with when it comes to space weather. Certainly.
You've talked to a bunch of power companies. Do they acknowledge any problems with having enough backup transformers in case there's a big storm and they get blown out?
They have not, as far as I'm aware, there's been nothing like that that's happened. Here, the power grid, the NERC, the North American Electrical Reliability Corporation, NERC for short, that's who we communicate with during these storms. They are required to report to the Department of Energy if they suffer a bulk transmission failure. I believe the definition of that, I'm probably going to get this wrong because I always forget, is something like if 25,000 or more people were impacted. Up to that point, they don't have to report it, not to DOE. They may have to do something else. That's the only reason I found out about that thing in Idaho and Washington, that small scale one, is because of press reports. I confirmed that there was a thing. I confirmed that the power industry said that it was a high voltage capacitor that tripped from the space weather storm. I just couldn't confirm that the power outage, which was around the same time, was due to the space weather storm. Is it possible? Yes. Is it not possible? Maybe. I don't know. But if it was to happen on a high level, you were going to hear about it because they're going to have to report it to the DOE. Sure.
Oh yeah, you mentioned Mars real quick, and that's like less atmosphere than the Earth, so they're going to be more susceptible to solar weather, space weather?
Possibly. Because they're also further away. I don't know what the capacity of these solar radiation sources would impact them, but I mean 30 chest x-rays? That's a powerful storm. And yes, just so you all know, we're responsible. If we decide to go to the moon, if Artemis 4 comes through and we actually land people back in the moon, we'll be responsible for astronaut safety for that entire mission, even their moon walks. If we build a moon base on the moon, right now, it looks like we'll be responsible for space weather on the moon. NASA is responsible for space weather for all the other probes looking at Jupiter or Saturn or asteroids or whatever. That's why they care about CMEs going anywhere into space. We just care about those right now going towards the Earth and Moon. We do go back to the Mars, however, we are probably going to be responsible for a lot of that mission going to Mars. So we work heavily with the Moon to Mars office at NASA as well in planning for the future Mars mission.
Any more questions here? All right, let's ask the Zoomers. Anybody on Zoom have a question? You have to unmute. I'll take that as a no.
Sounds like it. Sounds like a no to me.
All right, thank you, Shawn. Oh, I wish my dad was able to have watched that.
Yes.
That was cool. All right, well, Leonard, you're up.
Okay. I'll make mine short. Long-winded. Okay, I'm going to go through these really quick. Unfortunately, there was a lot of stuff. A lot of things happened.
We depend on you.
There's your clicker.
Okay.
I'm going to move this microphone a little closer to you.
All right, okay. Well, we got a new crew ready to go. Not to, let me see my notes here. If everything goes right, you know, we're going to have this set of people for Artemis 3 crew go into Earth orbit. And what this crew will attempt to do is rendezvous with some simulated lunar landers that NASA is trying to get together as a program for landing people, like Shawn was talking about Artemis 4 with an actual human lunar lander. This is sort of the early pictures of some of these things that they're going to try to rendezvous with. The key thing to watch here, you know, and you know, I write about this stuff, so I'm a little bit on the cynical side. I'm not sure how this is all going to work, but I mean, NASA is moving ahead. This is the next mission that they want to do, and they're going to have the Blue Origin group. Where are we here? Are we watching?
Yeah, I just got to share screen.
Oh, okay.
I always forget to share screen.
Okay, oh my God.
People at home are going, it's all small, Dewey.
Yeah.
Yeah, we can barely see it, but you know, you're taking care of us. We appreciate it.
Yeah. It's kind of,
All right.
you know, the whole thing, we got a space race going on. I mean, every time the new NASA administrator, after a while, I'm not going to say new because he's been there enough to be bludgeoned already by the media. You know, we got a real interesting thing going on here with a race to the moon. This is, nothing's happening here. Okay, this is not happening either. Hello, where did he go? Where'd Dewey go? All right, you're on your own now. Make up your own captions. Anyway, okay, let me just get back to the basics. Artemis 3 is, you know, a major capability that it has to be shown. Otherwise, we just don't have landers that are going to be given a thumbs up to land on the moon in the next few years. So this is a real competition, not only with China, but also between SpaceX and you've got Blue Origin, Jeff Bezos. So it's a real interesting dynamic. And if I can get these slides to go, I can tell you a little bit. Where did he go?
I don't know.
He disappeared. He doesn't want me to talk. Here we go. I need help.
Yeah.
Nothing's moving forward.
Can you use the space bar?
Is it not?
Nothing's happening on this.
Oh, it's not moving forward?
No. I gotta have some latitude for altitude.
Yeah, in 11 years of doing Skywatchers, we have never had a time when the speaker came and we couldn't get his PowerPoint to work.
Yeah,
But we have occasional.
we have our
glitches.
own problems.
Now this should work.
Should work. Okay, let me go back. I was trying to get back. Okay, there. I just want to make sure you saw what Blue Origin on the left, on your left, and then what SpaceX wants to do. Now the problem is, I'll get to in a few minutes. So it's a space race of flags between countries. China, it wants to land a human crew on the moon before 2030 is what they're shooting for. And there's every indication that they are actually moving that upward. So it's really going to be an interesting dynamic there. They had a very interesting test just a few days ago. They actually launched a vehicle, a Long March 10, and for the first time the rocket took off. This is sort of like Elon Musk and returning the first stage to a landing zone, but China has a whole different concept. They had a drone out there, a drone water ship, and it had all these nets in there and ropes and all. They captured it. So they're excited, and for good reason, because they've been dropping these booster segments on the population in China for quite a while. And people are getting a little upset. Can we get those, you know, so they don't crash into our town? So they made a really good showing of this particular vehicle. Now they're going to have to keep doing it and let's see where that's going to go. This is going to play into their lunar moon mission in the future, one thinks. Okay, keep an eye on China. Again, I follow this a lot. Next month, probably, I'm not quite sure what the day is going to be, but they're going to launch a new robotic mission to the South Pole and look for water ice. This is a robotic mission. Again, they've had a number of really important missions to the moon, all robotic, and brought back samples. This one is to land and actually deploy a little hopper that's going to jump around in a rover, and they're going to go into one of the darkened craters on the south pole of the moon, look for water ice. Is it there? If it's there, it's a big deal. Could be turned into rocket fuel, could be turned into oxygen for crews. So they're preliminarily looking at the South Pole, as America is, to set up a human tended base. Also, this is kind of cool that nobody's paying attention to. And I wish I knew what I wrote here. Okay, here we go. Okay, August 5th, you gotta watch the moon because there's a upper stage from an old SpaceX rocket launch that actually is gonna hit the moon. And nobody knows what's gonna happen. There's predictions, we may see a water plume, we could see dust, we could see something, or we don't see anything. But from an astronomical viewpoint, there's kind of a global interest in this impactor that's pretty well predicted exactly when it's going to hit. So anyway, it's a human-caused impact, and we know the time, and we'll see whatever reaction comes out of that. But it's pretty interesting. Just the other day, I was up all day trying to follow the SpaceX Starship flight. This is, again, uncrewed, but this is Elon Musk's unbelievable booster. I mean, it's just incredible. It's flown 12 times, and Flight 13 was a couple, yesterday. Was it yesterday? I don't even remember. It seems like it was like a year ago, but it was probably yesterday. Anyway, he tried to get this thing off the ground. They got down to ignition of all the 30-some watt engines on this thing, and it shut down because a couple of them didn't turn on. So it was a scrub for the day.
That's what they call it.
They call it a scrub.
So,
Yeah, but he's going to fly this probably next week. It looks like they're going to be back on track to try it again. So keep an eye on that. Kind of a historical note, it's fascinating. 50 years ago, we landed Viking 1 and 2 Mars missions on the Red Planet. And this was a first-time event, and really singular in its capability because it looked for life. It was designed to look for life on Mars. Had a long arm, grabbed some samples, put it in a little system inside the Viking lander, and it basically did some really incredible biology experiments on the sample on Mars. On that left side is a good friend of mine. It's late, he's gone now, but Jerry Soffin was the lead biology guy. There's the kind of equipment we put together and threw it on the Viking, inside the Viking lander. And it was a really impressive work by TRW and a lot of other contractors to develop a thing that said, if there's life on Mars, we can find it. Now, how do you do that down here back in 1974, 5, 6, when they were putting this together? And that's the cool thing about this whole 50th anniversary, because it asked that 2 spacecraft landed on Mars and asked that question: is there life on Mars with all that biological equipment? The answer came back. Can you repeat the question? That's my view, because in the 50 years that we've been discussing the results from Viking, it's more contentious today than it was back then about whether or not those biological experiments, or at least 1 or 2 of them, may have found life. And because we're getting much more sensitive to life here on Earth, the problems it has, we find life in a lot of different places that are very Mars-like, could be, maybe, a lot of question marks, a lot of and so it's an ongoing question, and that's why we continue to be fascinated after 50 years of Viking to even ponder that question still.
So they're telling about on Monday.
Oh yeah, Monday I'm at the Wings of the Rockies.
Yeah.
I'm moderating a panel. If you're interested in going to that, it's what 10 o'clock in the morning.
11 to 1.
I hope I'm awake for that thing. It's going to be great. I got to moderate. I got a bunch of panel people that worked on Viking or looking at the future of Mars exploration, and it should be a really interesting panel because again, 5 decades later, we're still asking almost the same question. Is there life on Mars? If it is there, isn't there, how do we find no or yes or whatever it is? I'm in the camp that we've already found it, and we're just going to replay some Viking experiments that worked well. And but who knows? It's definitely a new target for NASA for going to Mars with humans. Also, a big thing happened. China, on the left here, you can see a flyby of an asteroid just a few days ago. They rendezvoused with this thing, and they're circling it now, and they're going to actually dive down and do a sample return of this piece of an asteroid, which may be, according to some people, could be a relic of the moon. It could be leftover of moon material that helped shape our moon as we know it. On the right there is the Japanese Hayabusa 2 probe. It flew by this asteroid. He made a close approach and took a picture of it. Again, one of the weird things about the right picture on the right there is we're seeing a lot of these clumps of things that glued together. We got asteroid material that kind of comes in a cohesive nature, and so we're learning a lot more about asteroids, and because at some point one of those is going to be on a trajectory to Earth and could cause some harm. So we're learning a lot about asteroids. Okay, next thing. Oh, this is fun. I don't know how many people have seen the Starlink flyover. Have you seen the Starlink? Okay, good, bad, and different. But last night we saw. I honestly, God, I saw 50 of them. I don't know. They kept coming, and
So in the north,
yeah, they're really out there. About 12:30 at night, they start picking up, and it's just going by. It's all kind of. They're there, and there's a new private group that just got an FCC license to launch one preliminary spacecraft that can shine sunlight down to specific parts of the Earth. And what they want to do is put up thousands of these things. So light on demand. You need it for an emergency situation. The military is interested because they could, light up the battlefield and blind, whatever. I don't know. It goes on and on. But anyway, this is really an interesting development, and it's something to watch. It's sort of like, Starlink on steroids, but it with light involved. So.
a lot of us
Huh?
want to see that.
Yeah, a lot of us don't. I think it's very interesting.
It wouldn't be good for astronomy.
Again, the FCC just gave these folks a go-ahead to launch the first spacecraft in the series to try it out and deploy it and try to reflect light. There's a lot of different ground stations that are going to be involved, one of which, nobody's picked up on this, is Denver. So if you see bright lights in the night and you're wondering what time is it, never mind daylight or savings time. Anyway, it's going to be fun. Pentagon. Oh, my favorite topic is UFOs. We got more, another batch of brand new UFO material, UAP, unidentified aerial phenomenon. The Pentagon, and particularly Trump, has pushed for more information to be given to the public, and It's really becoming a very interesting batch of documents when you add up all of them. This latest batch is really intriguing because it goes back to the 1940s. And there's a lot of really interesting information because we've been paranoid about this for a long, long time. Edward Teller was brought in at one time. One of the documents from Los Alamos that got declassified was involved. So it's an ongoing, very interesting dynamic. I think the big story is, I don't know how many people here have seen Disclosure Day with Spielberg. We haven't seen it yet. I don't know what it is, but we're going to go at some point. So anyway, we're on the verge of something. Either it's all BS or it's UFOs, UAPs. A lot of initials. This is kind of fun. Two chefs in Russia got together and came up with new food for the space station. They jammed it in on the just launched a couple days ago Soyuz rocket with three space travelers, two Russians and one U.S. guy, and they got some really cool food up there. The first in the history of Russian cosmonautics was sent to the station on Soyuz MS-29 under the guidance of chefs. The cosmonauts on the ISS will create dishes based on video instructions from the chefs. They'll have some kind of thing with potatoes and caviar and some other thing with tomatoes. Dishes created by the team of gastronomy. This is great. We love astronomy, but now we got gastronomy in space. So, and caviar, special bread, and a childhood memory dessert, cookies, nuts, and berries, was created by Vladimir. He's a brand chef with some big restaurant alliance. So, you know, if you're sick of Wonderview food and something else, you get into space and you're going to have a hell of a time up there eating some great stuff. I think that was it. That's probably enough. We want to do a picture.
Yeah, anybody have any questions for Leonard? Any Zoomers have questions for Leonard?
Well, I hope not. I'll make up the answer. Okay, we should have a photo. We want a photo option here.
Usual routine, before we pack up the chairs and all that stuff, everybody get up here for the big group photo. And then,
and this is going to be put in the Wonderview